Continuing our discussion about constant of proportionality, if you look at page 105, example 3, asks, can you represent the total cost y for admission and x rides at the amusement park using an equation in the form y equals kx? So basically, with this equation, this equation only works for proportional relationships. So what we're going to have to do is see if these are proportional. In other words, see if our ratios are equivalent like we've done before. So basically, if the rides are x and the cost is y, if we divide the cost by the rides, that tells us how much it costs per ride, finding our unit rate like we've done again. So first one, if you do 25 divided by 1, that would be $25 per ride. And understand what's happening here is admission is $20, and then after you get in, then each ride costs $5. So one ride, you have the $20 to get in plus the $5 for the first ride. Two rides, you're going to be paying just an additional $5, so $30 total. So if you do 30 divided by 2, you get 15. That's $15 per ride. So we had $25 per ride, and now we have $15 per ride. I really don't have to go any further. The book goes ahead and shows you, if we do a third ride, it's $11.67 per ride if we average our cost out. Okay, so it's averaging out. The more rides you do, the less cost per ride, just because that $20 admission is getting kind of split up between more rides. But anyway, these are not all the same, and if they're not all the same, then it's not proportional. Okay, if we don't have equivalent ratios, it's not proportional, so it cannot be represented with an equation like y equals kx. If you look at the try it, balloon A is released 5 feet above the ground, balloon B is released at ground level. Both balloons rise at a constant rate. Which situation can you represent using an equation in the form y equals kx, and explain? So if you look what's happening here, again, we could make the time be the x and the height be the y, and we could find out, how many feet per second on average that it's going. So we've got, with balloon A, 9 divided by 1 is 9, 13 divided by 2 is 6.5 or 6.5. So already I can tell that those are not going to be proportional. Those don't come out the same. For balloon B, we'd have 4 divided by 1, which is 4. 8 divided by 2, which is 4. 12 divided by 3 is 4. So all those come out even when we do y divided by x, and so that is proportional. So the question is, which one can you represent using an equation in the form y equals kx? So from that, we could just say that balloon B would be the one that represents a proportional relationship. All of the y over x ratios equal 4. And so remember, going back to that equation, y equals kx, k is equal to y over x, constant of proportionality. So we would just substitute a 4 in place of k, so y equals 4x would be our equation. And again, what that's telling us is that the balloon is going 4 feet per second. Technically, if you look at both of these equations, in both of the cases, the balloon's actually going up by 4 feet a second, but we can't use an equation like this with balloon A because we had a starting height. Since we didn't start at ground level, it's actually not going to work, and we'll get into that more later. But basically, you want to double check it and take y divided by x just to make sure if all your ratios are proportional or not, if they're equivalent or not. So the key concept, just kind of recapping things again, if we have things that are proportional, we have this constant of proportionality k, and we find that by taking y divided by x, and we can use an equation y equals kx to represent the proportional relationship. So we're going to look at a few problems here on 106, starting with, do you understand number 3? Why does the equation y equals 3x plus 5 not represent a proportional relationship? And basically what it amounts to is that it's not in this form we've been talking about. So it's not in that form, y equals kx, so it's not a proportional relationship. The problem is that we have this plus 5 at the end. Okay, with our proportional relationship, we'll just have y equals something times x, like y equals 5x, y equals 1/3 x, y equals 2/10 x, whatever. We don't have a number that's added or subtracted behind it if it's proportional. Look at number 4. Same idea. They want us to tell if these are proportional or not, and then if it is proportional, they want us to identify what the constant of proportionality is. So you can see on A, they're subtracting 2 here, so we could say no. And again, we could highlight that they're subtracting 2, being kind of a reasoning there. On part B, you'll notice that just says y equals something times x, so that would be proportional, and then the constant of proportionality would be 1,000. K equals 1,000. And then part C, you can see they're adding 1 back here, so since they're adding 1, whoops, then that would not be a proportional relationship. Alright, we look at number 6. Half dozen cupcakes cost $15. What constant of proportionality relates the number of cupcakes and total costs? And they want us to write an equation. So basically what we want to do is figure out our unit rate. So we want to figure out how much it costs per cupcake. So we'll do $15. A half dozen would be 6. So $15 for 6 cupcakes. And then if you divide that out, is going to be 2.5 or $2.50 per cupcake. So if we take our equation y equals kx, our equation then would be y equals 250 times x. In other words, x is my number of cupcakes and y is our costs in dollars. We should be a little more formal with this on a test, saying x represents the number of cupcakes, y represents the total cost in dollars. But again, it's just $2.50 times however many cupcakes we buy is going to tell us what our total cost would be. So we're going to look at a few problems here on workbook page 27, starting with number 3. Water is dripping from a faucet into a bowl at a constant rate. Number of milliliters of water in the bowl, y. And the time in seconds, x, are shown in the table. What is the constant of proportionality for the relationship? And then part B, they want us to write an equation. So they are telling us basically that it is proportional by how they've got this worded. We would want to double check that they're correct probably. So again, if we do y divided by x, okay, so 320 divided by 20 is 16. 560 divided by 35 would be 16. Okay, all of these should be 16 when we divide these out. And again, that's what we would expect, that they would all be the same, because they basically told us that it's going to be proportional. So constant of proportionality, we got 16 every time we divided y by x. So constant of proportionality would be 16. Okay, so we could just say 16, or we could say k equals 16, and then write an equation. So if we have y equals kx, y equals 16x would be our equation. And again, just thinking about what this means, we did y divided by x, so that's how many milliliters per second the water is dripping, milliliters per second, so 16 milliliters every second. So 16 times however many seconds, that would tell you how much water would have dripped during that time period. Look at number 6. Some friends in college took a road trip to Florida. Use the table to determine whether an equation in the form y equals kx can be written for the situation, and explain your answer. So they're saying we are checking now to see if this is proportional or not. So miles traveled is the y, hours driven is the x. So if we do y divided by x, that's going to tell us how many miles per hour that they traveled, basically. So if we do 82.5 divided by 1.5, if you work that out, that ends up being 55, so 55 miles per hour. Then for the next part here, 137.5 divided by 2.5 is 55, so it's looking good so far. Next one, we do 232 divided by 4, and that's 58. Right there I'm done, because these are not all equal. Okay, so they averaged a little bit more, so they had a section where maybe they didn't have as much traffic, or they had a higher speed limit or something, that they were able to drive faster there, bumped up their average speed. And we do need to explain our answer, so we need to make an actual sentence here telling why we came up with this. So we could say something that, no, we can't use this equation because the ratios are not all equivalent, so it is not proportional. Or you could say some ratios are 55 miles per hour, the third one is 58 miles per hour, so it's not going to work. Okay, remember that y equals kx only works for if all of our ratios are equivalent and it's a proportional relationship. Number 8, the number of pizzas y and the weight of the shredded cheese topping x on the pizzas have a proportional relationship. When shredded, a 50-pound block of cheese is enough to make 150 large pizzas. Okay, if you notice, I kind of color-coded this, and you guys, if you want to do that, you can. If you have a colored pencil or something. Number of pizzas was the y, so I underlined in black things with number of pizzas, and then the weight of the cheese was x, so I underlined those items in red. So we want to find the constant of proportionality. So constant of proportionality, we need to do y divided by x. So with what they've given us, y is our number of pizzas, which is 150, and the amount of cheese is 50 pounds. So if you divide that out, you get 3. Now if you think about what happened here, we did pizzas divided by pounds of cheese. So what this means is actually we can make 3 pizzas per pound of cheese. So constant of proportionality would be 3. And then the question is, how can you use that to find how much cheese is on one slice of pizza if there are 8 slices per pizza? So what we could do is take that constant of proportionality. We could make an equation. Y equals 3x. There's a couple ways we could do this problem. One way at this point, since the y is our number of pizzas, what we could do is just put in a 1, which would be like for one pizza, and then we could solve for x, which would be how much cheese we would have on that one pizza. So they're multiplying by 3 if you divide by 3. That means there would be 1/3 a pound of cheese for one pizza. And we have 8 slices, so what we're going to do, we're going to take that 1/3 a pound and we're going to divide that by 8, and that would tell us how much we would have for one slice. If we do that, keep change reciprocal, and that would be 1/24 of a pound of pizza, or sorry, 1/24 pound of cheese for the one slice of pizza. The other thing you could do, the other option is if you could think about it as, it's one slice, so it's 1/8 of a pizza. So, another option here is we have 1/8 of a pizza, and then you could say they're multiplying, divide by 3, and then you'd be in the same boat here. 1/8 divided by 3, well, it looks different, but it'll come out the same, 1/24 that way also. Okay, so whichever way you want to do that would be fine. Number 9, for every 3 lemons Chrissy buys, the total cost increases by $1.80. So they want us to find the constant of proportionality. And if you'll notice here, they've given us what's going to be the y and x. Usually if money's involved, usually money is our y. We want to find the price per something, in this case the price per lemon. So if you do $1.80 divided by 3 would be 60 cents. Again, a reminder, even though you guys may be doing this on your calculators, you still need to show your work of how you got these numbers. No magic tricks and random numbers coming out of nowhere. So constant of proportionality would be 60 cents or 0.6. So then our equation, remember our equation is just like y equals kx, so that would be 60 cents times x. Or you could just have 6/10 times x if you wanted. Alright, then they want us to use the equation to complete the table. So 6/10 times x. So if they've given me 4 lemons, it's 60 cents a lemon. We do 60 cents times 4 would be $2.40. I'm going to go down to the bottom one here with the 18 lemons. That'd be 60 cents times 18 lemons, which is $10.80. Now the other two are going to be a little bit different because they've given us the cost and they're wanting us to find the number of lemons. So start out with your equation. If the cost was $4.20, that's our y value. Okay, $4.20 is our y value, so we'll substitute that in place of the y. And then we could say x is being multiplied, so we can divide. Okay, or if you just think about it, it's 60 cents per lemon. You take 4.20 divided by 60, and that would be 7 lemons. And then same thing for $9. They're multiplying, so we divide by 60 cents, and that is 15. Okay, problem like this, Generally, you might expect the answers to come out evenly. Okay, we're not probably going to buy like 3 1/3 lemons or something like that. So just kind of keep that in mind to make sure if your answer seems reasonable or not. And finally, number 10, for every dozen bagels you buy, the cost increases $15. Which equation represents the cost y and the number of bagels x? Okay, so if it's for a dozen, that's for 12 bagels, it's $15. Like I said, usually we're going to take our price divided by whatever it is we're talking about, in this case price per bagel. So if you do 15 divided by 12, that's $1.25. So $1.25 should be our constant of proportionality here if it's the same cost for each bagel. So $1.25 times however many we buy. So that would match up with choice D. So this should give you a good idea of how to work with the constant of proportionality, that y equals kx equation.